Hello kids, how are you? This is teacher Carla, and today we're going to start a new week. So, welcome to science class kids. Yes, so this week we're going to start with lots of fun. Again, alright? So now, get ready kids, because we're going to start now. Okay, zoom in. Okay, now on your book. Okay, get your science fiction book kids. And on page 387, alright? Lesson 8. Essential question, lesson 3. How do movements of the crust change Earth? How? Okay, let's find out. Alright, engage your brain, kids. Okay, on this part here, okay, so you know what to do. Alright, the first question. Find the answer to the following question in the lesson and record it here. Write it down here. So, how do Earth's interior shape its surface? So, how? Okay, so we're going to find the answers on the reading kids. Okay, so now in the active vocabulary, so lesson vocabulary. Okay, we're going to there are 8 words. Okay, that we are going to find, and we're going to write them down here when we read. Okay, all right, kids. Let's start now. Inside the earth. Have you ever dug a hole in the ground? What do you think you will find if you could dig a hole all the way to the earth's center? Active reading. As you read these 2 pages, put brackets around 4 words for the layers of Earth's interior, kids. So on this part, pages 388 and 389. Inside the earth. It's not really possible to dig a hole to the center of Earth, but scientists have done research with technology to learn what is beneath Earth's surface. Earth is a sphere made up of very different layers. Okay, so look at the image, kids. So we can see the layers here. Okay, the one which is in the center is inner core, outer core, mantle, and crust. Okay, so you gotta identify each Earth layer by its description. Then draw a line from your answer to the layer on the diagram. So on this part, you're going to fill the blanks with the largest portion of Earth's interior, made of molten metal, made of solid iron and nickel, thin rigid rock layer. Okay, on the second page, if you look closely at a slice of bread, you'll see that the crust is very thin compared to the inside of the bread. The same is true of Earth. Earth's crust, it is rocky. Outer layer, the crust is hard and made of many minerals. Earth's crust is thinnest under the oceans and thickest under mountains. The crust makes up only about 1% of Earth's mass. The layer below Earth's crust is the mantle. The mantle is the thickest layer, making up about 2/3 of Earth's mass. The mantle contains some liquid rock, but is mostly solid. High heat and pressure in the mantle cause it to flow slowly like warm plastic. At the center of Earth is a core made of metal. The inner core is solid iron and nickel. The outer core is molten liquid metal. The metal core makes up about 1/3 of Earth's mass and extremely hot. So look at this. Oh, it seems like pizza to me because of the shape. All right, kids, so look at this. Okay, from 5 to 70 kilometers, which is 3 to 43 miles. Then the other one is, wow, look at this, 2,885 kilometers, which is 1,790 miles, 2,217 kilometers, which is 1,410 miles, and the core, which is in the center, 1,210 kilometers, which is 750 miles. Okay, you can learn different things from these 2 diagrams of Earth's layers. Explain the difference. Well, I might say that one is circle and the other one is like a triangle. Okay, so do you see on the page the first two letters on the vocabulary? Well, the third one, the third first letters. We have crust, mantle, and core. Okay, let's move to pages 390 and 391. Plate tectonics. Okay, you can see objects in motion all around you. Did you know the surface of Earth beneath your feet is in motion too? Yes, it is. The Earth always moves. Okay, active reading. Earth's crust is a hard shell of rock, but it is not one solid piece. Many pieces of crust called plates fit together like a jigsaw puzzle. The plates rest on Earth's mantle. If Earth's mantle flows like warm plastic, do the plates move too? Yes, they do. The motion of Earth's plate is very slow. However, it happens too slowly to see. The theory that Earth's crust is divided into plates that are always moving is called plate tectonics. Some plates contain mostly continental crust. Others contain mostly oceanic crust. Many plates are made of a combination of the two. In some places, plates are moving toward each other. In other places, the plates are spreading apart. Okay, look at the map. Earth's crust is made up of large tectonic plates. So look at here. Okay, so we have the Eurasian plate, Australian plate, Philippine plate, Pacific plate, the Foca plate, North American plate, Caribbean plate, Caucasus plate, Nazca plate, Antarctic plate, South American plate, Scotia plate, African plate, Eurasian plate, Arabian plate, Indian plate, and Australian plate. Okay, now on the next page you can see, okay, on the first picture on the right, the Aleutian Island chain near Alaska form where the northern edge of the Pacific plate is pushing against the North American plate. The Great Rift Valley form where the Arabian plate is splitting the African plate into two new separate plates. Do the math, kids. Solve word problems. In the text, find the rate at which North America and Europe are moving away from each other. In 15 years, about how much farther apart will they are today? Look on the map at the plates that contain North America and Europe. Each year, North America and Europe are about 19 millimeters farther apart. Certain land features form where plates collide. Other features form where plates separate. Mountain ranges, island chains, and enormous valleys are some likely signs of a plate boundary. What can you tell by comparing the shapes of the continents with the shapes of Earth's plates? Okay, kids, now let's move to pages 392 and 393, plate boundaries. Okay, on this part, plate motion might be too slow to see, but what do you think happens where two plates meet over hundreds of thousands of years? The landforms we can see today give us clues. Active reading. Tectonic plates move toward each other and spread apart. Plates also slice past each other. Different types of plate motion produce boundaries that shape different landforms. Continental plates moving toward each other push up mountains. When an oceanic plate moves toward another oceanic plate, one of them is pushed down under the other. This collision can cause a deep ocean trench and an arc of volcanic island to form. When an oceanic plate collides with a continental plate, the denser oceanic plate sinks under the continental plate, causing mountains and volcanoes to form along the boundary between the plates. When plates pull apart, new crust form, a ridge on both sides of the boundary. Okay, on the next page, look at this. This is the picture of the Himalaya. The Himalaya, kids, it's the highest part on Earth. So now on the next page we have these pictures, the first on the top of the page Two plates can slide sideways past each other. Earthquakes occur often at these boundaries. At the San Andreas Fault in California, the North American plate is moving southward and the Pacific plate is moving northward. Two plates can pull away from each other. On land, this forms a rift or separation. Iceland sits across the separating boundary between the North American plate and the Eurasian plate. It will eventually become two separate land masses. As two continental plates move together, their edges fold and bend, pushing up mountain ranges. The Himalaya range in Asia includes the world's highest mountain peaks. The Himalayas are still growing today, as the Indo-Australian plate pushes against the Eurasian plate. Okay, now kids, on this part, draw arrows on the diagram to show a kind of plate boundary. Then draw a landform that could occur at that kind of boundary. Okay, kids, as we could read just now, okay, so on this part, talking about the Earth, okay, the crust, which is on the highest part of the Earth where we step on and where we are, okay, it is a very important part of the Earth, the crust. And as we could read just now, okay, we can know now that there are plates, okay? So this plate tectonics, kids, are very important because as you can see, the Earth is alive and it moves. Every time it moves. We don't feel it. Most of the time, we are moving and we're doing different things. But the Earth is always moving. Remember, kids, the Earth rotates by itself 24 hours. Every 24 hours, which is the rotation movement and the translation movement around the sun. Okay, but internal also the Earth moves. Okay, and these plate tectonics are the ones which do these movements. Some of them are very strong, okay, because the plate tectonics, they have to adjust every certain time. For example, as we could read, this one of these plate tectonics move 17 millimeters away every year. 17 millimeters. Maybe you might think, oh, this is not really much, but it is. But sometimes, but this plate tectonic is completely, how can I say, it doesn't move much. But for example, kids, in Guatemala, we are on a very, how can I say, strong area, which plate tectonics constantly move. And because we are surrounded, Guatemala is on this, San Andreas Fault, which comes from Alaska and goes to the Pacific Ocean, through the Pacific Ocean, and it goes from Alaska, passing through California, San Jose, California, to part of Mexico, the Pacific coast of Mexico, Guatemala, El Salvador, and goes all of it, all the American continent, passing through even to Chile. So all this area, kids, it's affected by this, San Andreas Fault, which constantly move. That's why, every certain time in Guatemala, in these countries like Chile, Mexico, California, and the United States have earthquakes. El Salvador too, because of this. Because this San Andreas Fault moves a lot compared to other ones, of course, And also there is another one, the Caucasus Fault, which also is very active. Okay, kids, now after this, let's watch a video about the plate tectonic, and you will understand a little bit better of this, okay? All right, let's watch it now. Ding.